Okay, I was originally going to title this presentation, "Why don't you just write the interesting parts?" But someone told me it's best not to start with a question, so don't just code it, generate it. What we're going to be doing today, talking about some history and why code generation at all, and then hopefully, having dispensed with that, the anatomy of a code generator, and then very briefly some final thoughts. I can be reached at kevin@mackey.name. When the .name top level domain arrived in, I got in ahead of all of the other Kevin Mackeys in the world. At least I had got to win one thing. I blog very infrequently in data-related things at kjmackey@wordpress.com, and I can be found on Twitter at Kevin J. Mackey. I normally don't do technology. I tend to tweet in haiku. I don't write my SQL in haiku. Select asterisk from table with alias where some predicate is an abysmal haiku and not great SQL either. So not technology related typically. A little about me. Been doing this for some time, as my white beard can attest. Hate the rain. I'm native Irish, so I got tired of being soggy and went to California. And now I'm here in the Midwest in Kansas City. Worked with Service Broker for a number of years and was an architect, also at a failed startup. I was a manager at one that didn't fail, but I would have had to stay there 15 years as a manager before SAP bought them. Oh well. Should I grow up, I hope to make a decent chocolate eclair. Had a lot of practice last year for obvious reasons. They call it choux pastry, but why should it have the consistency of leather is what I want to know. And I do keep trying things at home. You know what they say, use metadata to make your code do what you want. It's how the J.D. Edwards and the SAPs of the world, large-scale enterprise applications work. You fill in some metadata, you tell it what additional columns are there in the sort of user columns available for whatever you want areas. You tune your application via metadata, and then the application does its thing. I say use metadata to make your code, simply, and then go do what you want. Sadly, I haven't managed to arrange the latter part of that sentence nearly as often as I should like. But basically what we'll be talking about is how to make your code using metadata so that it just flows out on something like a production line. Okay. First major area, some history and why bother. Way back in the day when I indeed worked for Digital Equipment, they had a COBOL generator. COBOL is the only language I know where programmers get writer's cramp from all the stuff they have to write. It was a, you drew a flow chart on a graphics terminal basically and then pushed a generate button, and an odometer popped up that told you just created 36,000 lines of code to say hello world. Thankfully, things have moved on from there. In 2004, Kathleen Dollard wrote a book on code generation in .NET, which turned out useful for me in 2006. I was working as a consultant with some of Microsoft's internal IT, and they were moving from one version of BizTalk to another. The first one, I think, that used .NET, so the XML parser and everything was changing, and they needed to be able to prove that a given input document produced exactly the same output document in the old version and the new version, because their trading partners wanted to be able to send an invoice and get an acknowledgement back that they could still read, or a shipping notification that was readable. So we built a database that talked about the tests and all the documents that were part of that test and when the test was done and what the results were. But the database the people building the database or designing the database kept changing things. And we had a guy from Microsoft Consulting Services who wrote us a basic ARM, because this was way before Entity Framework, that required a set of standard CRUD stored procedures for each of the tables. And I got very tired of rewriting them when oh no, these 3 columns belong over in that table, and this one has a new one, and we're dropping that table or those 3 columns or whatever. So I bought the book and said, fine, there's got to be a better way. And after a while, they could change the database as they wished. We hit a button and we got hundreds of stored procedures out the other end. It worked. In 2017, Nick Harrison wrote something called Code Generation with Rosalind. He works in the financial industry and has the idea of encoding business rules in metadata and then writing a program which reads that and in concert with the Rosalind compiler in Visual Basic, just manufactures the code to implement those business rules, which an impressive feat. The risk there is to write a code generator that's more complex than the thing you're going to wind up wanting to run, but the book itself is very good and helps try to avoid some of those issues. In 2017, Bill Fellows and others wrote the book, the BIML book, an XML grammar / script for generating however many hundred SSIS packages you need to do ETL. And as SSIS packages are really just text, some specially formatted XML, I've also used BIML script to produce stored procedures and DDL for in-memory data structures. Quite useful. Still in 2017, apparently 2017 was a good year for the concept of generation. Telesys showed up out of Capgemini in France, Laurent Guérin, whose name I may well have just mangled. It uses the Apache Velocity templating engine, and it's a Java-based tool, but it can write anything out at the other end. And in 2020, we added Microsoft added code generators to Visual Studio, where in fact, at the time your code is being compiled, you have access to all of the variables and the scoping and structures, and you can inject new additional code to implement business rules or whatever is actually necessary. The kind of thing you might have used reflection at runtime, this is at compile time, and then the compiler takes that and merges that into your output. So it would seem that code generators been a long time coming, and their time is certainly here. Says who? Well, says me and a bunch of other people. Rocky Lockda in his intro to Kathleen Dollard's book said, if you can describe your code generation process as an algorithm, then just generate the darn thing. Alan Cameron Willis et al. Writing about T4, the text template transformation toolkit. That's not a phrase that comes easily off the tongue, but basically to get the full benefit of code generation, generate code, not just configuration files. Remus Rosano, who wrote most of SQL Server, Service Broker, said you should be able to just generate activation stored procedures because they just read from DQ messages. They then shred them. Someone I think may have their microphone open because I can hear myself, and I never ever want to do that. It's bad enough other people have to listen to me. Service broker activation store procedures, DQ messages, shred them, and then persist them. It's the same process. The only difference is elements in the XML columns in the database. So that's easily templatable. And Nick Harrison of the Rosalind compiler user says, okay, get the best of both worlds by generate compiled or compilable code from your business logic. Okay, that's who, that's history. Why? Well, we're already doing it. We've got old code lying around. No programmer that I know starts from an empty notepad and starts typing code, or few enough of them. We've got stuff lying around. We find it on Stack Overflow. or MSDN doc pages. They tend to be a little dry, but they still get the job done. Sometimes there's actually just too much to deal with. If you're dealing with service broker and they have, say, 20 messages, different XML structures, well, you'll need 20 activation stored procedures to DQ them and shred them and persist them. So there are 20 objects there, but then you'll need a services, target and source services for those which have source and target queues depending on them. At that point, we are at 100 objects. There was 40 each, 2 per message type. If some of your queues are elsewhere on other servers, you might have routes that take you there, so you need 20 more elements, SQL Server objects. So we're 120. Messages need to be persisted, typically in tables that look awfully like the messages, so why not just generate them? Whether you do or not, you're going to need another 20. So out of 20 messages, you have 140. When we were building at DataView, the service broker application we were working with, we had over 200 different message types. There was just too much. If you do it by hand, you get what I prefer to call artisanal code, which is great if you're making pottery. You know, these are uniques. Everyone has slight differences. But if you're writing code that way, you have a problem because when something goes wrong, where is it and why is it here and not over there? One of the things I like about generated code is its consistency. It's either all right or it's all wrong. And if it's all wrong, you fix something in the metadata or in the template and suddenly everything is all right again. In terms of too much to do, Angular, if you've ever typed ng space new at a command line, it goes away and thinks a bit and then comes back, and you've got in your directory structure there, folder structure, over 30,000 files suddenly appear. You won't need them all, but you'll need some subset of them, but you get 30,000 plus. That's just too much to do by hand, which is why they went that route. So how do we do it? Well, the same way we're already doing it. Got some old code, we do a global search and replace, we then fix the results of the above because global search and replace is something of a blunt object. We extend some samples we've found or .NET quick starts. We've got code snippets or templates that SQL Server says, I want to make a new stored procedure. Okay, here's a block which mostly contains comments, but it's got the create procedure statement for you. If you then get tired of some of that, you might write yourself a good string replace function which handles sort of step 2 and step 3 a bit better. Global search and replace and then fixing what's there. The other way, well, we've all seen Dynamic SQL. This comes from a set of Microsoft scripts with their new, I keep wanting to say worldwide importers, but it's in fact wide world importers, and I just can't get that right around correctly. But WWI, they supply a WWI_preparation database, which is a set of metadata tables for schemas and tables and columns and constraints and so on, and then a suite of dynamic SQL scripts which operate on that and will build you the structure of the importer's database. Quite handy. I know for a fact in every situation exactly how many single quotes you need in your dynamic SQL at any point in time. It's however many it takes to stop the rest going red. Dynamic SQL, I'm not as fond of it as I used to be because it reminds me of some of the early websites I worked on with classic ASP, that after 3 months, if you needed to modify it, it was actually easier to rewrite it from scratch because you look at it and go, what was I thinking? Or how did I think that? Somewhere at the end of your dynamic SQL, and you have, okay, execute this string, whatever it is by now. It works, but we're hoping for more maintainability. Different approaches are templates. This is XSLT, and a template is nothing more than Swiss cheese, basically. You've got the basic structure around the fixed stuff. Use wide world importers. Excuse me. Wide world importers, set quoted identifier on, and so on. Then you've got the bits that are in blue, where the stored procedure name will go. Create procedure XSL value of select equals SP name, $SP name, and each time through this particular template, it will slot in a different name for a procedure, and then you iterate across a set of columns, root/table/columns, and you put in all the columns, where the select statement and the from and the where are kind of fixed, and then the other bits slot in the holes. A different kind of template. This is a Python pyrotemp template, but basically the same thing. The green bits are the holes that you're going to fill at runtime when you, to use an old term, basically mail merge your metadata with your template, and you get code out the other end. Create table table.schema, table.name, and then you iterate something that hopefully has a list of columns in column_list, and then you dump out the information about the column name, the data type, and so on. And down towards the end, the template may have the capability of saying, okay, if the column dot is nullable is true, then put in null, else put in not null. So within your template, you can have some conditional stuff as well. And then at the end, maybe some extended properties where you add in description, table description, and then each time through this particular template, you get a new table with a different set of columns, a new name, and different descriptions. So that's the why and something of how we're currently doing it. Let's take a look at what a code generator actually should look like. Everything breaks down to threes. Have you never ever noticed that? All it is some metadata matched with some templates, and that matching done by some driver program. It's a fairly simple concept. Not always easy to do, but certainly a simple concept. And continuing with the law of three types. There's the natural metadata that a database may know about itself. Hybrid, which is okay, all that, plus there's some additional stuff we need to add. And then custom metadata where you do your own thing. The next couple of images, I'm sorry, they were suggested to me by somebody else, not my fault. The natural great white sharks among us, information schema or sys objects. You've got information about the schemas that are there, the tables that are there, the columns that are there, and dumped out in some way that the template can actually deal with. So expressed as XML, you might have something like this: the schema, the table name, column name, and within the column name, you've got other things like its data type, the precision, numeric length, and so on. So it's basically some XML that you might be able to iterate across in some way. So code generation anatomy metadata in XML matched with an XSLT template, which is one of the easier on some levels ways of dealing with XML, by then a C# program. And this is the concept that Kathleen Dollard had. So if we take a look at that, we've got from the WWI database, and in this case the preparation database, you've got root, a given table, some columns, column name, table name is people, application is the schema. Is this the PK or not? Is PK equals 1 or 0, and so forth. A fairly straightforward and relatively simple XML structure, which obviously could be extended to handle multiple tables as needed. Processed using an XSLT style sheet template call it as you will. And this is what this might look at. The style sheet takes in the name of the table as a parameter and also a value now, which is just a time. And XSLT can also have variables. The key thing to remember when working with XSLT, variables are invariant. Once you set the value to something, it's stuck that way. XSLT is actually a functional language. So variable version 1, template version 1, that's the way they were when I originally built this, and I never had to change it again because it's a demo. In real life, they would change, definitely. SP name, which we saw earlier, is a concatenation of whatever the table was that was sent in plus underscore select 1. So that's going to be the name of our stored procedure. Variables can get a bit complex in XSLT. PK column, where we iterate across all the columns, and if it's set to 1, then select the column name, and that's going to end up in PK column. And we do something similar for schema, except instead of going through all the columns, we just choose the one that's set to PK and pick up the schema because it's the same for all of them. So preparatory work in our template, and then basically it's just, okay, call a template called open stored SP, do the body, and then close, and we're done. And OpenSP is what you might see in a lot of DDL for building stored procedures. I wrote this originally before drop if exists worked, so sorry for the archaic SQL in this case. Here's where we stuff in the version and so on, just there so that we can see which version of the template, which version of the generator was used to build this thing, whatever this is. And we pull out the value of now, but just the first part of it. And then the rest of it, create procedure, select $SP name, and that's that template. The template body is select, and then apply this template, which iterates across with XPath root table column, so it does it for each of them. And that just says, okay, put in the column name, because we're doing a select. And oh, by the way, if the position is not equal to the last, happily enough, put in a comma, otherwise don't. And then finally, close SP, which is just, okay, this is the end to the original begin, wherever that was. Begin procedure, end procedure. And then our C# is simple. Get the table columns from the database, hand it back as an XML document. Define some of the parameters, the table and now, which is system.datetime.today, and which we're going to pass into the template. And then make a compiled transform, pull in generate SQL template, which we were just looking at, and then using StreamWriter for test.sp.SQL, tell the transform the transformation we built that, okay, this is the XML document, this is the arguments for passing in the name of the table and now, and write the output to this StreamWriter, and then clean stuff up. It is the driver program tends to be relatively simple. Most of the work is done in putting together the metadata with an eye towards the templates that you're going to use, and then in the templates themselves, what's conditional, what's not. One key thing which comes back more than once is you have your metadata correct if you can use it for more than one template and generate more than one type of thing. Okay. I'm looking for SQL Server. Let's do that. Okay, this is a very empty test.SQL at the moment, a test.sp.SQL. So if I go back to here and say, okay, generate select.exe, people, off it goes and kind of finishes in something like a hurry. And back here we say, okay, reload it. And suddenly we've got use worldwide importers, wide world importers, drop the procedure people underscore select one. Here's our select statement where the primary key person ID equals what it was that we passed into the stored procedure. It's kind of, all right. At that level, it is that simple. That's the last XSLT we're going to be taking a look at. So let me see where I can get back to where I was in the presentation. Okay. I told you I didn't choose this image. I don't know if that's a HARC or a source, but it's some combination, which is really what hybrid metadata tends to be. Stuff from the information schema or sysobjects, and then other things that might be useful. Like, okay, these are parent-child relationship tables, so we might have some additional information about foreign keys and such like, or entity grouping. Now, okay, for this particular set of generation, we want to just generate the things dealing with the shopping cart and all around it. So, okay, we would tag the information in the metadata with that so that we could then say to the generator or the driver program, okay, we're just handling the shopping cart now, go do that, because that's what we're testing, that's what's changing, and don't build the entire world. Operation ordering. If we are putting together DDL for parent-child tables and the interlinking between them, we'll do the parents first and not then the children. Or perhaps, in fact, we have a driver program that can do parallel work or serial. And okay, identify those things that can be generated in parallel and others that might not be. Again, using XML, the same kind of structure that we began with, just pulled out of the information schema, and then some additional things down at the end which describe the other things which might not be immediately available from just pure natural metadata. It tends to get a bit messy, but basically build the metadata that you need to solve your problem wherever you assemble it. With custom metadata, you've got basically anything goes. Computed columns or dimension and fact tables, and then if dimensions types, these are slowly changing dimensions or whatever. Other business rules are source to target mapping. If we're in fact moving data from source A into target B, a data analyst will sit down and write up some source to target mapping. Why should it be that then a developer has to sit down with that document and try interpret it and then turn it into code? Why not build the document in some iterable form, possibly captured in our humble Excel or dumped into tables or some such way, and then use something like BIML to read that and go generate the 142 ETL packages that were necessary. There's no, if you can describe the source target mapping cleanly enough, there's no reason to have someone step in to try and interpret that into a quintessentially boring ETL. The better part would be to read said document, develop the template in BIML or anything else, doesn't really matter, and generate the XML that forms an SSIS package. You might also be interested in capturing metadata versions for that service broker operation that we at DataView have been involved with. We're at just recently 280, version 280. That's not because we've had 280 versions of it. At some point, some program manager types decided, okay, well, we need to go in tens because it matches this other thing that we're doing, and we want to line up the version numbers. Frankly, it doesn't matter. But if you version your metadata, then okay, we need to work with a different branch of code, an older one. We'll regenerate the code from 278, even though we're currently working on 280. This should indeed be possible. These tables are from the WWI preparation that Microsoft provides, and there's tables there for the schemas, for tables, for indices or indexes, columns, and so on. That's there. Key thing, don't go too wild with your metadata unless you're building a product or writing a book, as various people were. You're actually charged with producing code. If you spend more time producing wonderfully impressive metadata, someone in authority will suddenly ask, where's all the code that's supposed to be there? So, build as much metadata as is necessary and as little as you can get away with. Having said that, this is a language I put together for metadata. It was last year when I wasn't making shoe pastry for eclairs. I had to do something else. 2020 was a kind of special year. So I put together a language which captured basic data type information and the indenting or the containment of product within subcategory allowed me deal with things like, okay, there's a foreign key, there's a parent-child relationship between these entities. Other information like product category ID, PK is true and it's required true. And by the way, auto is true as it's also generated by the database and in increment 1, 1. That would allow the template that was doing an insert to say, product category ID is auto true, which means it's handled by the database. I don't need to insert that value. The database will take care of that for me. So notwithstanding, don't go building your own metadata languages and so forth. Yeah, I did, because it actually worked. We've used this now to build ASP.NOR.core APIs and so on. It's just a simple, relatively straightforward way of describing the data that we're going to work with. Okay, metadata. Do as much as you need and as little as you can get away with, but do it with a view to what the templates are going to need. So metadata matched with, okay, some templates. Here, anything you like. XSLT, very, very powerful. As it turned out, it didn't scale terribly well across the group. I wound up being the person who knew XSLT enough to make all the templates, and I got bored doing that, so I said we need to use something else that everybody else knows. You can use T4, the Text Template Transformation Toolkit. String template comes from Terence Parr, who wrote Antler, which is a parser generator, and he needed something to basically produce the code for the parsers he was generating, so he wrote string template as a templating capability. That works rather well. Python libraries are, there's an enormous number of them. You can use the Rosalind compiler and basically build your C#, your whatever code, and just pass it to the compiler and off it will go. Telesys, out of France with the templating engine built on Apache Velocity, or BIML. BIML is an interesting, as I've mentioned, it's both the driver program and the templating engine itself, both as an XML grammar and pure BIML script. But the general purpose BIML engine takes that, applies the metadata, and spits out whatever it was you actually wanted. You don't need to be able to read this. This is page 1 of very many pages that returned when I said to Google, show me Python template libraries. And there's just enormous number of them out there. A lot of them have to do or were built originally to make HTML pages, but HTML is just text. DDL, DML, they're just text. C# code is just text. So they can be well enough used. It's really, okay, what are you comfortable with? What might turn out useful to you? Things to look for though, looping structures, you've seen that. We need to iterate across a list of columns. We may need to iterate across a list of tables, and within that a list of columns if we're actually going to deal with whole large numbers of them. So some kind of looping structure. Do this thing, output the column name and the column data type and null or not null as you need. Conditional expressions, as you saw. If this is nullable, then output null, otherwise output not null, kind of thing. Also useful if there's a block of code that shouldn't be executed because this particular if you're doing parent-child tables, and some parents don't have children, then if you can encode in your metadata something to the effect that child tables exist for this, then you can say if child tables don't exist, don't generate the code. Rather than generating stuff and have an if statement in the code that skips over that. No, just simply don't put out the code into the resulting file. Macros are handy if the templating tool has them, just because if you keep repeating the same block of template code, then why not make it a macro and call that. It makes your template smaller, easier to read. You're aiming for simplicity, which is key. If your templating language, again, is more complicated than the programming language you want to produce, then just write it in the programming language. Again, that's kind of what you're being paid for. So unless you can make it easier to produce the program code by going this approach, don't use this approach. Okay, some examples of PyRaTemp templates, which is the Python templating library we use. Partly because it had what we needed. It's simple, it's small, and it's fast. And we all knew Python, and you can use Python elements within it. So everybody seemed happy, and I was, because then other people could write the templates. So some CRUD stored procedures, XPath parsing, or whatever else. Let me see if I got this right. Yes. So for CRUD stored procedures, we have a set, and we're going to be using these later so that we can see these in action. But as I said, Swiss cheese, the green bits are the holes, which each time through this template we will dump a different schema, a different table name, and whatever is the PK column. And on it goes. This is the select, this is insert, and so on. Delete. With some code up here that says, oh, by the way, if skip s xs is set to no, then manufacture stored select stored procedures. Otherwise, just simply drop down to the end here and move on. Basically, don't generate this code. as you wish. Something similar, producing XPath parsers. The messages we were using in Service Broker were XML messages, and we initially began by using XPath to parse out the elements of the message that we want and dump them into a messages table. And that worked early on, shall we say. So make a messages table. Again, enumerate over something called column list, which must be passed into the template, and then good reasons for if, because there'll be different data types. If the data type is decimal, then do something else if it's something else, and so on. And then at the end, put in a comma if we're not finished, or don't if we are. And so on it goes. As it turned out, when we got well beyond 20 messages and all receiving at the same time, we discovered that XPath parsing in SQL is very expensive in CPU and tempdb usage. It hurt a lot and not cheap on memory either. So we then moved to, okay, let's make C# XML parsers as SQL functions, defined as SQL functions, which is here. Call that, table definition is that, and so on. So this allowed us to use C#'s capability to instantiate a forward-only, very lightweight XML reader, and then cycle through it and pass the information back. And that cut down on the memory usage. It stopped tempdb usage and was faster than SQL anyway, so that worked out rather well for us. So different templates for different tasks. CRUD stored procedures, XPath parsing, or C# code generation. When putting together templates, make your decisions in the template, not in the generated code. If code doesn't need to be there because of some condition, then make that decision back in the template and don't generate it. If you're writing stored procedures by hand that might read against a configuration table using the name of the procedure as the key, object name, proc ID works very, very well for SQL. It saves you mistyping it and not getting your configuration. If you're generating the code, this template already knows the name of the stored procedure, so just hard code it. These stored procedures ran millions of times a day, and why have SQL Server do more work than is necessary? Use macros and includes where you can. And the key point, you know you have your metadata right if you can use it for more than one template. And then the third part, a driver program. It tends to be simple. We saw an example of it. It's a command line parser. What should I do? It needs to be able to acquire the metadata in a form useful to the templates, and then merge the templates and the metadata. And that's really all. When I said useful to the templates, this is a query that goes against Microsoft WWI preparation. And if I execute it, life is good. We see all the column names, the data types, the maximum length, until we get here. nvarchar max. The others have nvarchar, and then over in the next element we've got 50 or 20 or 256. But for nvarchar max, Microsoft includes it in the actual data type itself. That's probably because the other column is maximum length is numeric, and they couldn't, you know, MAX doesn't work terribly well as numeric. The problem is if we hand this to the template as it is, then the template's going to have to check, okay, if it's nvarchar, great. Does it have max in it? Oh, no, it doesn't. Okay, go pick up the maximum length from somewhere else and put it in. Oh, yes, it does. Then we need to do something else. And that's just more work than the template should be doing. So basically, prepare your metadata or hand your metadata to the template in a way that works well for the template. And in this case, what we do is if we find it's nvarchar max, we move the max over here. We're returning text. The template won't care because it's all text to it anyway. So this is a key approach. Prepare your metadata or return your metadata in ways that the templates expect. Acquire the metadata in a form useful to the templates. We've gone a little further and we've now exported a lot of the metadata into Azure tables matched with the same PyroTemp templates, but now stored in blobs, and the driver program or programs are now Azure functions with JSON. And the JSON looks a bit like that. The task, generate DW objects, which is in fact the name of the function to invoke, passing the name of a template to operate on, and the output file to create here. In terms of versions, -1 says I don't care about the version, give me the latest one, and put it in a folder called DW. And then Java files, generate them. Here's the templates. Because we're going to produce a different Java file for each, we can't simply have an output file name, but here's a folder structure in blob storage to put it. And again, I don't care what version, just give me the latest. No. Yes. So that looks a lot like, okay, invoke this, pass that JSON structure up into Azure and get back to me. Depending on how Azure reacts, this sometimes takes a little longer than others, but all that's done is posted that message off to an Azure function, which then will drops those different tasks into an Azure queue, and different functions will take care of picking it up. We'll come back to this in a moment, but basically Azure functions, same templates, and metadata in Azure tables. Using Python for parsing, argparse, which is the arguments, because that's a library that works very well, PyODBC to pick up the data from the database, and then PyroTemp as the templating engine. And let's take a look how that is. So generate CRUD. Okay, make me some stored procedures. These are the arguments, pass in a template, tell it don't make a select statement, don't make an insert or whatever. By default, they're false. And then it says, okay, go process all tables. So this picks up data that query that we saw with its case statement to figure out what n varchar max should be, and it builds up a dictionary. And this generate code says simply, okay, gets passed in the version, the table name, the set of columns, the output file name, the template to play with, and then whatever one of these options are set. You basically build up a dictionary in Python, passing in columns, which is in fact a list, and invoke pyrotemp, and then says, okay, write out the output file. Process all tables just cycles over that. It says, okay, give me all the tables, and then generate code for each one of them. So if I go back here to our Python generator. Okay, invoke the driver program, tell it use the CRUD template and create a SQL file called CRUD stored procedures. It gives us some information about what was going on, but generating code for people on all of those, and looking for SQL that says, oh, okay, something new happened, and suddenly we have stored procedures for people, for cold temperatures, and in fact, we've got 15,780 lines, 89 lines of SQL code that we didn't have not terribly long ago. And it kind of works that fast. Once you get the metadata in place, you get your templates in place, then you can drop into the kind of continual development and so on by simply regenerate. Someone once asked me, do you store this code in source control? And I said, no. You store the templates, you store the metadata, and the code itself is irrelevant because you can manufacture it again. This typically happens to me. I write a generator and I give it a particular name and then discover, oh yes, it does other things. So it's the same program, which means it's pulling back the same metadata, but this time we have our XPath parser that we need to work with. Okay. And finally, just so that we're not always producing SQL, oh, they're still lying around from before. Well, I'll get rid of them. Again, the same driver program. And they're back, but they're back at 6:25, which is 3:25 LA time. So you know if you have your metadata correctly, if you can use it to generate different things. Okay. Some final thoughts. All you need in terms of metadata is all you need and as little as you can get away with. If you're not creating a product or writing a book. In terms of templates, choose what works and can be manipulated or maintained, sorry. And reuse metadata and drivers from multiple templates. The resources for all of this are on GitHub in Kevin J. Mackey /SQL.Saturday.LA 2021. So the slides, code samples. But there is one thing I want to look at, which is this. We checked the time when we kicked off the generation of code up in Azure, and this code is new. It's out of 6:25 my time. If we download that to somewhere useful, the point being is, yeah, okay, your demos worked, Kevin. You made some CRUD stored procedures. Whoopee, that's impressive. It's like Entity Framework can't do that, right? There's no point in just having a few little stored procedures lying around if that's all we're dealing with. So this created just now. So if I pull this in here, it says this is a little big for tokenization and wrapping and so on, but it's, you know, real. And I did mention that templates change in terms of version. But the key thing I want to show, and the important thing I want to show, is this. There's 1.3 million lines of SQL that didn't exist 10 minutes ago. This is why you do code generation, not to make a few, a half dozen stored procedures or a bunch of C# or DDL, or even, you know, 10 ETL packages. When you've got some serious task, some large-scale task facing you, it's a good approach to take. You need to step back and think about the metadata you're going to need. You also need to solve the problem. You need to do it once so you know where the holes are going to be in your Swiss cheese when you turn your code into a template. But that's why you do it, not because you can make a few stored procedures. And finally, I wondered, were there any questions? Or did I lose my audience entirely? Okay. Well, in that case, that's what I've got. Yes, I can imagine people's heads can hurt because it has done that to me also more than once, but it's an interesting and valuable approach that seems to work. And as I said, 1.3 million lines of SQL, that was for one set of stored procedures we use. There are actually, I think it's 3.5 million other lines of code, be it C#, XML parsers, or DDL and additional DML. And for reasons I could never understand, I was tasked with generating Java code that would interact with the database that we were busy populating with all of these service broker messages. So at one level above sort of easily generatable JPAs. So every time now we regenerate all the structures, we regenerate all the stored procedures, we regenerate all the Java. So as I said, all that code's up on that GitHub and also the slides. Anyway, thank you very much, and I'm glad you enjoyed it. Much appreciated.